welcome everyone. You can see that I'm working on the Tetris problem and I'm working on part 7, but this is the beginning of part 7. So if you're following along from our Git repository at Groxio Learning Tetris video, you'll want to add to the end of part 6. So go to the feature branch, part 6. Okay, so let's talk about where we left things. So we built an inspection protocol, and this is something that we can probably test fairly easily by just printing out a string. And we can likewise test the toString function. And I think that probably it's enough to go into the console and take a known block, inspect it, and compare the actual to the expected. So let's go ahead and do that now. That'll also give us a chance to kind of tinker around in the console and make sure that things are happening as we expect. So let's look at our tests. So we want to write a couple of tests. One, the test should flip, or should actually convert brick to string. And I'm going to say actual equals so I'm going to set those values up, and then I'm going to say assert. So that's the shape of my test. This should fail. And sure enough, it fails because actual is not the same as expected. That's great. So let's say actual is a new brick that we're going to pipe to. And I think we did an actual import. Yes. So we could pipe that into, or actually we need to do Tetris, because toString would otherwise be overloaded. So, and the inspected is, we're going to actually get that either from our test code or from the console. Let's get it from the console. So I'm going to say, I'm going to create a new brick now. So alias so now I have a new brick, and so I could say, or I could say brick to string. So here it is. That's lovely. So I can actually say, my expected, we could copy that directly, can't we? So lovely. And so I've made my usual mistake. I probably won't get that right until, I don't know, by the time that we finish this series, you know. But you got to live with what you got. Okay, so the next step, so we've done just a rough test. You could probably throw some more complex tests against this. I don't think it's necessary in the teaching series. If you want to tighten it up, you're welcome to do so. The next test is going to be should inspect bricks. So we could also do this in the console. We could say brick.new to in that to io.inspect. Let's see what that gives us. Yeah, uppercase there. And let's pipe that to, and this just, it's going to print that, isn't it? So that's not going to help us. So let's go ahead and, so basically we're losing all the new lines that I need for the inspection. Well, I guess I could add them back in. I could add them back in like this. Let's see if this gives me a good approximation of what we want. So we're going to use what's called a HereDoc, which is a multi-line string, if you will. There's my HereDoc. And so I want to do some assignment. So that is so I expect this thing, and so the new lines are actually in there, right? And so Elixir is going to left align my strings. It's going to truncate all the white space on the left based on where I keep the quotes. So I can then say actual. So let's do the actual first. New brick, and then I could pass that to look at that. First time I've remembered this whole series. It's gonna be a good day. And this might be off by a new line or so, but we ought to be able to tailor it. Okay, so where did we break? Tetris, brick, inspect. Oh, okay. Oh, IO inspect the brick. Or just inspect like that. Yeah, so basically what's happening, I'm not calling brick.inspect, I'm calling inspect. And I've told the system how to manage new brick with my protocol. So okay, so there's an extra new line that is on the left is the actual, and this is the inspected. So we could actually do a new line here. Does that do the job? Oh, nope, I'm off by 2 new lines now. So so probably what I need to do is add the new line in there like that. See if I can do. Yeah, so what I did is I had a string, and with string interpolation, I plugged in whatever was in the actual, and then I added a new line to the end of that. And I said that should be the same as what we get. And sure enough, it is. So we're happy with that. So one of the things that is going to happen with this is that as I move around the default implementation of my brick, like maybe I change this direction, these pieces, the inspect isn't going to tell me that we're going to have to play with the inspect as well, and that's going to be frustrating. So one of the things that we can do is we could build a regular expression with this in it and compare against those expectations, or we could say assert that our string includes this portion or even this portion. But for now, I just don't think we're going to be playing with this quite that much. So maybe what we'll do is kind of future-proof ourselves a little bit with our API. So I think maybe that's the only major thing that's going to change. I might be wrong, but we'll see. But let's get this from, so let's call that XCenter, like that. And maybe we could say that brick so XCenter is going to be 40, and then just let's have a function to return that. We might want to compute that later on. I kind of like that idea of computing that later on. So def XCenter, and all it's going to do is return XCenter like that. So let's see if that much works. Okay, so we need to plug that in with interpolation. So so let's do that now. So that's a Tetris case. We don't really care about that one. This needs to be XCenter like that, right? And sure enough, we are good to go because our XCenter, that's just an integer, and we've dropped it in right there, and we're pretty sure that things are going to start at the top of the screen, which we like. So that'll work fine for us. So I think that probably the next step is to think about adding some color. And this isn't so long yet, so let's go ahead and do that in this section. So let's have the colors for a brick. So we need a couple things. So the color for a brick, and then I'm gonna basically pick off the name, and I'm just going to do this with pattern matching. So if it's a L, and for each of these, so I have so these are the random names right here. So let's go ahead and do this. And I'm going to basically put a cursor right there. I'm going to put a cursor right there, and I'm going to say def color, and then a colon, and now I have the name all set up, right? And since that's matched, I can go ahead and define a color right there. Of course, we don't want them all to be blue. Maybe this one is green, and maybe this is orange, and maybe this is red, maybe this is yellow. So I'm not sure what the Tetris colors are, but that's probably a good place to start. And I wonder if this should live. Yeah, this should definitely live in the block. And maybe one of the things that we should do is allow me to add a color. So after I've done all the translation that I need to do within points, maybe I need to add it with color. So let's do this. Probably not near this part, but def with color. And I'm going to say, and so basically there's a bunch of enum.maps. We'll do that the same way. Points, and then a color. So if the color is, no, that's fine. So so basically, I'm not sure how we're going to represent the colors now. They might be colors as atoms. They might be colors with numbers. I don't really care because we can change that later on. And this is one of the few plus sides of dealing without type specs. This is going to be a little bit more flexible for me. But the main reason that I don't use type specs when I'm teaching is that there's a lot of extra clutter that I think gets in the way, and type specs can lie, especially when you're dealing with junior developers. So for teaching and basically to keep the code clear, I'm going to keep the type specs out. But just know that this might change from what it is right now. So right now, we're going to do enum.map over points, and we're going to call function point. Now I'm going to call add color of point. Right, so now I need to implement this add color. That's going to be private because basically it deals with a point and not points. So we want most of our API to be public. So add color. So if something already has a color, I am going to go ahead and return the point. I don't really want to add something that's already there. So if I get an X and a Y and a color, I'm just going to say X, Y, color. So basically the idea is that as we're doing all the heavy manipulation, we're going to keep our data structures as light as they can. Once we add the colors, then we'll be able to basically, when we prepare or after we prepare our block, when we're ready to convert the block to the final form, maybe we'll drop the color in there. And that'll work with, after we've translated and done all the movement and everything. We can go ahead and add the colors in and be kind of set with the final form that we're going to render. So let's see how this looks. So I can say alias. Let's go ahead and import it. So there's a new, so now I can say color, undefined function color. So what did I call that thing? I called it color, and it takes a brick. But I haven't saved that. Let's import it again. That's normally why I use an alias instead of an import. So that works. How about a random new random? Great, beautiful. So now we're extracting the color, and let's say let's look at a Tetris points.width color. Let's go ahead and create a couple of points, 0, 0, and 1, 1. And that's out of blue, something like that. So it's yelling at me somewhere here. There we go. Tetris points is undefined. Oh, gosh. All over the place today. Okay, so there we go. So we've added color. So what if it already has color? Then I'm still okay. So transpose, translate. So I'm going to say call this move to location. And I'm going to go ahead and label this. So that's the point, and I'm going to label this. So this gives this kind of obscure function better documentation and helps us understand what it does. You need to add tests for the color codes and the points.width color. That'd be a great exercise for you as we kind of move into the live view portion of this series. So this is a good place to stop. We've learned a lot. We've actually taken Tetris, the Tetris model, and we've created the pure functional part. It's actually not 100% pure functional, because with a pure functional code, if you call a function, you should expect to get the same response every time. But some of our stuff is random and some of our stuff prints, so it has side effects. But everything else is pure functional. And since we implemented that way, and since we implemented with a style that allowed us to have reducers, we're going to have code that tells stories, like the code in our tests. So if you look at the brick test, this is a beautiful story that we tell right here. we could say, okay, we start with this point, and then we mirror it, and then we flip it, and then we rotate it. This is just a beautiful way to think about the individual piece, right? And so if you want something to play with, you could actually run some assertions. Like one thing that you might want to do is assert a field, right? So the structs have fields of the names and colors, and you can assert that the field has actually moved left one, or moved right one, or moved right one, or moved down one. That is actually, the field is actually doing what it's supposed to do, rather than asserting everything at the end here. So that's probably a great place to wrap up. Enjoy the Tetris model, and let's think about how we're going to incorporate that model into our game. Take care until next time.